A motor is equipped with an optical shaft encoder to measure the motor speed. The optical encoder provides 200 pulses per motor revolution. Now, encoders are very popular digital devices. They can be used to measure the speed, even the direction of the motor and things like that. So, a microcontroller equipped with a real-time interrupt capability is used to measure the motor's speed. Okay, so the data when the motor is moving, which is equipped with an encoder, is fed into microcontroller to measure the speed. The RDI interval is 32.768 milliseconds. The microcontroller counts 372 pulses from the optical encoder in the RTI interval, which basically means every 32.768 milliseconds, the microcontroller basically counts 372 pulses. So in 372 pulses, every 32.768 milliseconds, right? Remember, it was mentioned here earlier that optical encoder provides 200 pulses per motor revolution, which means one revolution, you have 200 pulses. And since we are trying to measure the speed of the motor in RPM, and because this number is in milliseconds, to convert, have to divide this by 1000. And if I divide this by 1000, it actually becomes a numerator. Therefore, I have 1000 milliseconds, which is equivalent to 1 second. Now that we have converted into second, I need to convert that into minutes. So I divide this by 60 also, because it's in the denominator. Now it becomes a numerator, correct? So therefore, I have 60 seconds here, which will convert that into minutes. And if I now do the math, here pulses and pulses will cancel out. Seconds and seconds will cancel out. Millisecond and millisecond will cancel out. Now what I get is just simply going to be in the RPM and the magnitude 3405.76. 3405.76 rotations per minute.